Hello students of class 9, and the topic of discussion we had in the last class was about the structure of atom. As we have already, it was the revision part, as we have already completed our syllabus for chemistry. So in the last class I was talking about about the various scientists who made their experimental investigation regarding the structure of atom by J.J. Thomson and Rutherford. We also talked about the drawbacks, and then we talked about why Rutherford selected the gold foil for his experiment, and then and what was the postulate for Rutherford's model of an atom. Now we will be discussing now today about the drawbacks of Rutherford model of an atom. Like in fact, why Rutherford's model of an atom failed. In fact, you just think about yourself, like suppose you are in a marathon race or you are in a running race, and then what happens, you go on running and running, and then at one time you feel drenched out of your energy. Now Rutherford has given the model that the electrons will revolve around the nucleus, right? So naturally, when the electrons will revolve around the nucleus, it will undergo acceleration. So when it will undergo acceleration, like suppose if you compare yourself running a marathon race, and then at one time you will be drenched out of your energy. The same thing happens is that when an electron will undergo will move in the circular orbits, and then it will undergo acceleration. So obviously at one time what will happen, the electron will lose out energy and it will ultimately fall into the nucleus. But actually that does not happen, and that is why these revolving electrons, if they go on revolving around the circular orbits, and then they will fall into the nucleus. But in that case, what will happen? It does not happen. Why it does not happen? Because atom as a whole is quite stable. So in that case, if it falls into the nucleus, then what will happen? That means the atom is quite unstable. So since it is not unstable, that is why Rutherford's model could not explain properly the correct model of an atom, and hence because if actually the atoms is unstable, then what will happen? The matter would not have existed in the form that we know at present. That is why means atoms are quite stable. So that is why Rutherford's model was not the proper investigation. Of course, he made some progress regarding the model of an atom, but actually Rutherford's model failed because he could not completely explain the proper revolution of that electrons. And because, as I told you, that electrons, if they go on moving in the circular orbits, then what will happen? At one time it will lose out energy and ultimately it will fall into the nucleus. But it does not happen because actually atom, in that case, if it falls into the nucleus, it will be quite unstable. The atoms will be unstable, but actually it is not, because if it is unstable, atoms are unstable, then matter would not have existed in the as we know it. So that is why, as I told you, that Rutherford's model was not that successful. So it was next after Rutherford, it was Bohr's model of an atom. And Bohr, what he did, he told that only certain, what were the postulates of Bohr's model? He told that only certain orbits, which is known as the discrete orbits, in which the electrons are allowed to move. And also the second one is that while revolving in discrete orbits, the electrons do not radiate energy. So actually what happens here is that when you are talking about the Bohr's model, so what happens, Bohr had postulated that there are certain discrete orbits in which the electrons can move around the nucleus, right? So what happens here is that the nucleus remains in between and the electrons revolve around the nucleus. But what happens is that suppose, and he named it as the Rutherford's model, he named it this discrete orbits as the energy levels, and when they revolve around the discrete orbits, what happens? They do not radiate any energy. That means they do not, the electrons do not lose out any energy, and that is why it does not fall into the nucleus. Now these discrete orbits, actually the nucleus, they remain inside the atom, right? And then it occupies a very small, as you have seen, which is being postulated by Rutherford, that it occupies a very small amount of the space in the atom. And the electrons, when they are, this orbit are named as K, L, M, N, right? So it goes on. So these energy cells are named with the capital letters A, then capital letter M, capital letter N, then capital letter N. So when these discrete orbits are actually, they are energy levels, that means these orbits are supplied with energy, right? And then please remember that when an electron moves from the inner orbit to the outer orbit, then what happens? It absorbs energy. The electrons, they absorb energy, and when it moves from the outer orbit to the inner orbit, then the electrons emit energy, right? That means, that is why the electrons are able to revolve around the orbits in discrete orbits, and they do not fall into the nucleus, and that is why the electrons are quite stable, right? And then these energy cells, please remember that, as I told you, that these discrete orbits are supplied with a definite energy level of their own. That is why they are known as energy levels. Now we come to the next part, is the neutrons, and it was J. Chadwick who in the 1932 he discovered another subatomic particle, and that was known as neutrons, and it was found that these neutrons does not carry any charge of its own. That means they are neutral, and but they have a mass which is nearly equal to that of the proton. So the mass of an atom is the sum of the mass of the proton and the neutron, right? That means and it is actually present inside the nucleus, and the neutrons and the protons together, they are known as the nucleons. So as I told you that the neutrons are neutrally charged, and they do not have any charge of their own, and the mass of the atom is equal to the sum of the mass of the neutrons and the protons. So I hope it is clear to you what is neutrons. And then there actually, as you know, that there are some rules where by which you can know that how electrons will be distributed. Because the electrons are distributed, the number of protons is equal to the number of electrons in an atom. So how electrons are being distributed, you will know it through this way. Like there are some rules by which you can know that how the electrons are being distributed. So now in the first cell, 2 electrons can be distributed. That means the K or the first cell, what happens here, 2 electrons are being distributed. In the L cell or the second cell, it is 8, right? So in there is a rule, there is a formula by which you can find out, that is twice n squared. So if n is the number of orbits, that is 2 into 1 square is equal to 2. So that means the number of electrons that can be accommodated in the first cell is 2. So in the second cell is n will be 2. So 2 into 2 is 4 into 2 is equal to 8. So that means the number of electrons in the L cell or in the second cell is equal to 8. So similarly in the third cell, 2 into 3 square is equal to 9 to the, 2 to the, 3 3 is a 9 into 2 is 18. So that means in the third cell or in the M cell it is 18. So now we will have our discussion further, and till that time I'd like to thank you for watching the video, because it is for your good that you need to have a better concept, and this is a very important chapter for chemistry. Thank you very much.